to present this webinar. It's a pleasure for me to talk about this topic. I've been doing research on it for quite a number of years, and I find it fascinating to discuss with people. What I'm going to talk about, as you can see from the title, is essentially the effects of food and drugs on the brain, and particularly as the brain ages, and how we can do things to help it age better. And there's a lot of information in the popular press, and what I want to do is try and put some of this together in a coherent story. So to begin, let me just give you the basic finding and the main takeaway point of my research, and I think where we see drugs and foods affecting brain function. And that's in this first cartoon, which is that drugs are essentially foods for many people, as you're going to see when I discuss specific drugs, and that foods and drugs are both chemicals. And there really is no essential difference between how a food acts in the body versus how a drug might act. They're all just chemicals. Some of them have effects that we would prefer or prefer to avoid. Sometimes drugs can be nutritious, and sometimes foods can be quite toxic. And they all can affect the brain in various ways. That's what I want to try and summarize in the next 40-45 minutes. And I encourage you to ask questions. Just type them in, and I'll try and incorporate the answers as I go along. All right, so to get started, what I want to do is take everyone shopping to my favorite place here in Central Ohio. When you drive into a grocery store such as this one, you'll frequently see, the name of the store and food and drugs. What I'd like you to do next time you drive into such a store is to think this, that food is a drug and that drugs are food, and this is probably why they're sold so conveniently in the same store. It's an interesting concept, but a simple one. And I think when I'm done, you will agree that we need to really view the things that we consume as just chemicals that will have positive and negative effects. So let me get into what some of those effects might be. When we examine how a nutrient or drug affects how the brain functions, we have to take into account how those chemicals influence specific parts of our brain. And I'm going to introduce a few basic neurotransmitters. These are chemicals that the brain uses to communicate with itself and the rest of the body, and talk about how drugs affect those and how foods affect those systems. So first of all, we need to realize that some of these neurotransmitter systems have diverse effects. So I'm going to begin with a chemical called acetylcholine. Runs across the top of the slide. And acetylcholine is a chemical made from our diets, the things that we eat. You'll see some of them in a moment. The acetylcholine molecule is made in neurons, and the acetylcholine itself is released in these colorful areas that you see superimposed on the brain. So acetylcholine, because of where it projects in the brain, influences our vision and how we see things, our ability to make judgments and coordinate our movements and to even feel sensations. It's also very important for us to experience rewards or memory, to make a memory even about what you learned from this webinar. So acetylcholine plays a big role in learning and memory. So let me sort of unpack that and give you a specific example, which I think kind of makes my point about the role of acetylcholine being so diverse depending upon the part of the brain it's in. So if you're sitting and reading out loud to yourself or to someone else, you might come across the word ball. And in order for your brain to even process the vertical lines in the L and the curves in the word in the letter B, your visual cortex needs acetylcholine to help that happen. Without acetylcholine, you would have trouble distinguishing, is this word ball, bill, bull? You see what I mean? Also, what acetylcholine is involved in is helping you understand, well, is it a round ball? Is it an oval ball? How do I say the word ball or bold, block? What's it sound like? And finally, in the frontal lobes, acetylcholine is involved with helping our brain process, what do we do with balls? You may be thinking as you read the word ball, would I throw it up, drop it down, hit the ball, and where is it? Is it here, there? All of these things that our brain is doing with that very simple word as we're reading requires this transmitter, acetylcholine. So when we ask a simple question of the brain, when does acetylcholine turn on? It turns on when we're paying attention to something like reading the word ball or reading, Or in the case here, if we're lying still and we're measuring our EEG over the frontal lobes, we can see the red arrow pointing to a line, that squiggly line on top, which is an EEG wave that forms over your frontal lobes, and it tells you that you should pay attention. Something important is about to happen. Now, what would happen if we didn't have acetylcholine? Well, if we didn't have acetylcholine, if it degenerated for some reason, we would have the lower line. So we were trying to anticipate something important. We were expecting something important, like someone's going to throw a ball at us, or something important is about to occur. Without acetylcholine in our brain, we can't pay attention. We lose track of what's going on. And I should point out that one of the main changes that we see in the brains of people with Alzheimer's disease is a loss of acetylcholine. So when you tell an Alzheimer's patient, you know, in a few minutes we're going to go to the store and buy you some shoes, they may hear you and understand what you're going to do with them. But as soon as you leave the room, they've completely wandered off and forgotten what they were going to do, what you told them about. So you need acetylcholine to learn, to pay attention, to read the word ball, to understand what to do with things. And these are some of the problems that Alzheimer's patients deal with, especially during the advanced stages. They may forget what balls are for. So acetylcholine is a chemical in the brain made from the nutrients in our diets that is critical to allow us to pay attention, to learn, read, and to know what things are for. So how do we make acetylcholine? Well, as I mentioned, it's from the things that you eat. So we get acetyl groups from the sugar in our diet. So common table sugar is enough. There are many sources of acetyl to making acetylcholine, but sugars are the most common one we use. And then choline, which comes from a lot of things that we find mainly as lecithin in baked goods. So donuts contain actually a lot of sugar and quite a bit of lecithin as a baking agent. So what do we find then is that because of choline's role and sugar's role in memory, we notice that many of us like to have those items on the left in the slide, donuts, first thing in the morning. In fact, this is our brain telling us that we've been sleeping, we've been inactive, we haven't been eating, and now our brain wants to use some acetylcholine to pay attention and learn. That's what we'd like to do when we're awake. So fortunately, there are many places out there available to us, because we want them there, that sell us donuts. Or we can also go to various places and order smart drinks, and they're all over the place. You can buy them in grocery stores, such as Wenk's Grocery. And in those smart drinks, you will find the things listed on the bottom, and you'll notice that choline and lecithin and inositol, which is another form of choline, are all in smart drinks. Why? Well, because many years of research, such as that I've contributed and some of my colleagues have shown that we need choline in our diet, we need sugar in our diet, and so what we do is our brain directs us to go find those things in the morning. There's a reason that Dunkin' Donuts and all these other places are around donut stores and Starbucks to sell us these essential ingredients that we need to make this essential transmitter so that we can pay attention and understand the word ball when we read it, or understand what a red light means. So the nutrients in our food are converted into transmitter chemicals that are released in specific parts of our brain that allow us to do these things. So if you do have a donut in the morning, that is one way to get the choline you need, or you can simply buy it over the counter. And here are some examples of choline in various products called memory boosters or mind enhancers. But it's the same compound. It's a chemical, but the interesting thing here is that choline in the form of a donut we would call a food, whereas choline in the form of this choline citrate or mind compound we would view as a drug. So really, are donuts drugs? And you can see how the line begins to blur when foods have effects on brain chemistry. And this is actually a very common thing, and we're beginning to appreciate exactly how important food nutrients can be. So what I want to do then is go through a couple of other transmitter systems like I just did for acetylcholine, and show you how the things that you consume influence them and how they influence how you feel. So I just have, here's the next transmitter, dopamine, and for the most part it plays a big role in happiness and making you smile. Well, exactly how? During the past few years we've come to realize why we smile and how we smile and what makes us have a genuine smile. We all know what genuine smiles look like, and we all know what false smiles. And if you're an actor or an actress, you perfect the control of your facial muscles so you get it right. Well, dopamine, it turns out, is involved in genuine smiles. On the bottom of the slide on the right, you can see some circuitry in the brain, and all of that originates in an area called the basal ganglia, which is an area rich in dopamine. On top, you'll notice that a smile that is false originates in a completely different part of the brain. Although the same facial muscles are used, it's a very different effect. So when we're genuinely happy, dopamine gives us a type of smile that looks genuine. But when we fake smiles, dopamine's not involved. So let's continue with this a little bit further. What does dopamine play a role in? Well, essentially, anything that you do that is pleasurable, makes you smile, will involve the production release of dopamine. Now, you'll notice right away that dopamine does something very, very different than acetylcholine. Acetylcholine doesn't have any role to play in making us happy. So what do we do every day, or what might we do every day to release dopamine in our brain to make us smile the way this cartoon character does? Well, when people use illicit drugs like amphetamine, cocaine, opiates, and so forth. Drinking coffee releases dopamine, which makes it rewarding. Having sex, drinking alcohol, and those other things. Eating chocolate. And you'll notice at the end that food stimulates the release of dopamine. We're now beginning to appreciate that food can be just as addicting and in the exact same ways that marijuana or sex or amphetamines can be addicting. So actually, let me explain how that happens just a little bit. When people eat high-fat foods, our brain rewards us and says, thank you. Here's a little dopamine to reward you. And so this is an ad from the Lard Council, as you can see, from many years ago. But we've always known that when somebody eats a lot of lard or high-fat foods like ice cream, that they'll feel better for a while. And one of the reasons, there are many, but one of the major reasons is that high-calorie foods release dopamine in our brain. And more than that, this rather busy slide makes one major point, that our brain is built to make links, connections between rewarding things like eating and reinforcing changes in our brain to say, go do that again. And it turns out that there's another transmitter system called orexin. Orexin's job is in the morning is to wake you up and say, go eat. But more importantly, it also interacts with dopamine, that big blue neuron on the right that says VTA. That transmitter, working via dopamine, is released when we eat high-fat foods, foods that are tasty, delicious foods. And it stimulates our brain's reward center to say, wow, that was wonderful. Let's come back and do that again tomorrow, or even maybe in an hour. We literally become addicted to food, the chemicals in foods, via the same neural mechanisms involving dopamine that also will addict us to things like heroin, nicotine, coffee, chocolate, sex, whatever. As far as we can tell, the way our brain evolved was to take advantage of rewarding high-calorie foods and encourage us to go find more, which brings me to one very important point about food in the brain. You need to realize that your brain will try and make decisions about the things you eat that it wants that may not always be optimal for good body health. And you'll see that as I go along. That sometimes our brain encourages to eat things that our body would prefer that we did not. And donuts falls under that category. Third transmitter I want to talk about is serotonin. This is one that is intensely studied, not well understood. But we know it plays a role in sleep, dreaming, and moods. And I think everyone knows that what we eat certainly affects how we sleep, and sometimes even the nature of our dreams if it's particularly spicy food, and even how we feel during the day and how happy we might be. But serotonin is a little bit different, as you'll see. Serotonin also can make us feel a little anxious. So what we find is that depending upon what you eat, how much serotonin you make, you may become either happy, elated, drowsy, sleepy, or even anxious. And with serotonin, it turns out to be very much due to a balance. Too much serotonin produces the symptoms on the top. You might become anxious. You might have trouble sleeping. Sometimes people take antidepressants that enhance serotonin, and they notice that they have, their stomach doesn't feel right, or they have sexual dysfunction or loss of interest. Too little serotonin can be just as, somehow disorganizing to our behavior. It may induce panic or obsessive-compulsive disorder, or obviously not having enough serotonin will lead us to be depressed. So we are constantly, via our diet or maybe the drugs we take, which as I pointed out are really the same thing, we induce imbalances. We try and get the balance just right so that we're not making too much serotonin or too little. So how do we make serotonin? Again, it's from the diet. We take in some amino acids. The key one is tryptophan. And on the right side, and once it gets across the blood-brain barrier, we make serotonin out of it. And our brain uses that as a transmitter chemical to induce us to feel happy or anxious or, to break our depression and so forth. So where can you get tryptophan? And this raises some really interesting issues. We can have a glass of warm milk or just milk, some peanuts, wonderful sources, meat. We just had Thanksgiving. And that brings up an interesting point. There's been an urban myth around for many decades that the reason that you become drowsy after Thanksgiving is all that tryptophan in the turkey. Well, turkey, of course, does have tryptophan, but it has many, many other amino acids, as meats do. And all those other amino acids actually compete with tryptophan. And actually, tryptophan almost always loses. So we do not become drowsy after Thanksgiving or after eating meat or milk because of tryptophan entering the brain. We now understand that that was just a myth, and it's not how the brain works. The brain carefully regulates how much serotonin it makes. If you give it a lot of tryptophan, it usually will simply destroy it, metabolize it, and if any extra serotonin is made, it probably just destroys that too. So there are many other reasons we become drowsy in the afternoon and sit in front of the football game on Thanksgiving Day, but it's not due to eating tryptophan. Now, tryptophan can also be found in eggs and spinach, so there's a lot of places for it. And if you're going to consume it, it's probably best to get it from these natural sources rather than through a pill. So moving on then, now that I've introduced these three transmitter systems, how do the foods affect them and affect our thinking? And also, because I mentioned this thing about aging, I want to get into aging now and introduce that as a factor as well. And let me remind you at this point, if you have questions, by all means type them in. Happy to take a small break and address those. I'll just sort of forge on, and if I say something that isn't clear, please type in a question and I'll deal with it as they come up. There will also be some time at the end of my presentation if there are questions. So how do foods affect thinking and feeling? I get this question a lot, and it's very difficult to answer. And I try to sort of separate it into three basic approaches of how we look at the things we consume, and then how do they affect us. So how do they affect how we feel, how we think, and how our brain ages, or in fact how our body ages. They're related, of course. So I like to divide them into the short-term effects, the medium-term effects, and the long-term effects. Things that happen quickly, things that happen over a period of weeks, months, and finally the effects of the things, that drugs and nutrients that we consume that affect us over a lifetime. So let me get into that. How does food affect us, our brain, across our lifespan? Well, the fast-acting ways first are obvious ones, and I've mentioned a few already, like coffee. You wake up in the morning and you have some coffee. It helps stimulate your brain. In fact, we now understand that coffee is vital for stimulating acetylcholine, and I'll come back to that. Sugar affects our brain very quickly. It's our brain's primary source of energy. And also drugs of abuse, such as heroin, marijuana, and others, can have very immediate, meaning within minutes, effect on how our brain functions and therefore how we think, how we feel. The intermediate effects are what we call precursor loading. I've mentioned tryptophan already. So we eat things like specific carbohydrates, minerals, vitamins, lecithin, and fruits and vegetables, things that have items, chemicals, molecules in them that we need day to day, or that we might be able to store and not have to eat every day. But if we were to stop eating tryptophan for a week or two, our brains would begin to notice it, and we'd feel anxious and maybe irritable, and we would slide down that curve I showed you a moment ago. Then the long-term effects. These are the things that we eat, drugs that we take, that affect us over the lifespan. So let me unpack a few of these to give specific examples. First, I mentioned coffee a moment ago, and you already are aware of acetylcholine. It turns out that when you wake up in the morning, your brain does not have a lot of acetylcholine. So what do? You go have a donut or something like that, maybe a bagel. High glycemic foods tend to be great sources of chemicals to make acetylcholine, things that are very unhealthy for your body, but it's what your brain wants. And what happens to that acetylcholine? Well, unfortunately, sometimes the acetylcholine we make is not being released. So what's a great way to cause our brain to release the acetylcholine it's making? Drink some coffee. So what do we do in the morning? We pick up a cup of coffee and a donut, and our acetylcholine neurons are fed, and they become stimulated, and the coffee helps the acetylcholine become effective. So you can see that there's a reason that all of these coffee donut places are scattered around. We want them to be there. If we didn't, if our brains didn't want them, they wouldn't be there. Nobody would be selling them to us in the morning. And this is why the lines are so long in the morning and not long for coffee and donuts in the evening, because this is when our brain wants it. So coffee can stimulate acetylcholine in an immediate way. Now, the intermediate effects that affect our brain slowly over a period of days or weeks, well, these things do affect our mood, but generally what happens is that they just give a bit of a bias. And I mentioned tryptophan. But what if you didn't have enough vitamins, or your mineral supplements became low, you didn't have enough iron? Well, if you didn't have enough iron, for example, you might not make enough of dopamine. And without the dopamine, what we find, especially in extremely anemic people, is they have trouble paying attention. They sometimes feel lethargic. They feel a little sad. And then if they take some extra iron supplements, they feel better. So generally, what our brain needs are these precursors, these things that we get from our diet that our brain uses to make the transmitter chemicals that it needs to function and make us feel normal and think reasonably. The long-term effects we are beginning to understand better and better. And essentially, what it comes down to is the long-term aging in our brain is entirely related to the fact that we must eat. And because we must eat to survive, we do something that is incredibly dangerous to our bodies and particularly our brain, and that's that we breathe. I know that we've all learned in high school or college that we need oxygen, and of course we do. But oxygen is also very, very toxic to our tissues, and so the job of hemoglobin isn't so much to bring oxygen to the tissues as it is in our blood to keep the oxygen levels low enough that we don't outright kill every cell in our body one at a time. So how do we protect ourselves from this deadly oxygen? We eat antioxidant-rich foods. And you've heard this many times in the popular literature. Antioxidant pills, antioxidant foods, what are they? They are colorful fruits and vegetables, fish oils, and I'll get to some of those. The oxygen that we're breathing produces injury, one cell at a time, and that produces inflammation. And so what's the other thing that we do? We eat anti-inflammatory. So we're told, have some spices. Aspirin is wonderful. Vitamins, especially the fat-soluble ones like vitamin E, wonderful. Anti-inflammatories. Nuts have vitamin E in them. So what we're doing by eating these foods is to protect us from the consequences of eating, which is rather ironic, but that's what keeps us alive. So the risk then is due to the fact that eating requires breathing. So let me show you why that's the case. So here we are, and actually every other organism on the planet, whether you're a bacteria or a virus or a human, needs to consume the energy between carbon bonds. So fats, carbohydrates, proteins, they're all carbon bonds. And that's what you're seeing in front of you, those two silver balls, and there's energy between them. So we gobble the energy between them, and we call that energy calories, and we get some wonderful energy so that we can, make our brains function normally and walk around and live a normal life. What we do then is the carbon that we produced is left over. So the solution that organisms arrived at over billions of years ago was to simply breathe in that wonderful oxygen. And so the oxygen comes in our lungs, and we connect the oxygen, a carbon, together, and we make CO2, carbon, two oxygens, and that's what you see there. And then we do the best thing, of course, is we exhale it out, and of course nothing ever works perfectly, and there's a few oxygen molecules left hanging around. And this is where things get dicey. The oxygen becomes the culprit here. The oxygen hanging around, not really doing anything, begins to attack our tissues, as you can see, and one cell at a time might be lost due to the oxygen. And then the red lines, you can see there's inflammation forming. And so over time, as we eat, we must breathe. And because we breathe, we bring in the oxygen, and we get this slight imbalance. And the longer we live, the more of this oxidative stress and inflammation we induce in our body, which is why the only thing that correlates with the probability of dying is how many days you've been alive, which means how much have you eaten. So what do we do? What are we told to protect ourselves? We eat protective foods, fruits and vegetables, or we simply eat less, calorie restriction. So let me unpack both of those. First, the antioxidants. These colorful items protect us from the oxygen we consume. It's the color, the pigments in the blueberries, raspberries, in the vegetables that protect us. Those are the antioxidants. So the oxygen attaches itself to those colorful items. And the more antioxidants a particular product has, the healthier it is. So you can see here that some things we eat, like prunes, raisins, strawberries, that are very colorful, have a wonderful antioxidant activity. But look over at the left, and this is an interesting finding. Chocolate, and the darker the better, is very colorful. So chocolate actually is highly beneficial because it's full of antioxidants and some other compounds. The interesting thing about chocolate now that we've discovered is that men who eat chocolate live longer than men who do not eat chocolate, all things being equal. And there's no benefit for women because it turns out that chocolate has an estrogen-like compound in it, and that's why the men benefit by having that extra estrogen. Women have their own estrogen and don't seem to benefit until after menopause, when they become chocoholics. Now, chocoholism in postmenopausal women is due to a loss of magnesium in the body. No one knows why exactly, but there's a lot of magnesium salts in chocolate, and that's what women who become chocoholics after menopause are doing. So chocolate is very dark and rich in antioxidants that protect us from the consequences of breathing. So go out there and get some chocolates when you're having your donuts and coffee. Now, also inside chocolate is an interesting compound that was discovered a few years ago. It is called anandamide. That's Sanskrit, if you don't know Sanskrit, for inner bliss. And it turns out that anandamide is a marijuana-like compound. You can imagine the surprise people had. Anandamide is as potent as the active ingredient in marijuana. So when you're eating some chocolate, you're actually eating a marijuana-like compound that you can actually get high from. You'd have to eat an awful lot of chocolate. So most of us never experience anything like a marijuana high because we simply don't absorb enough of it. Nobody's going to eat enough chocolate. However, we believe that the anandamide will contribute to the enjoyment of eating. So think about that next time you have a nice piece of dark rich chocolate. Wonderful protection from oxygen and this little benefit of anandamide. And what you're looking at here are three-dimensional reconstructions of what anandamide looks like and what tetrahydrocannabinol, or THC, looks like. And this brings up another point. Any nutrient chemical molecule inside our food that looks similar in a three-dimensional way to a chemical our brain actually makes will interact with our brain. So the reason that THC in the marijuana plant can actually an effect on us is because chemically it looks like one of the chemicals that our brain uses. This is one of these interesting rules. If it doesn't look like a neurotransmitter, then it's not going to do anything in the brain. And you can see how similar these two molecules look. Going on with the same concept, I mentioned to you it's the color in the foods like the chocolate, or as you can see, beets make galangan, and cinnamon and curcumin, and teas make quercetin. Look at what you're seeing there. Lots of ringed structures. It's the rings that catch the oxygen, protects us. These are the antioxidants that you hear about. And finally, resveratrol, which has been in the news a lot lately, is also multi-ring structure. It is in the skin of red grapes. Its job for the grape is to defend it from fungus. So it's an antifungal for them, but it's an antioxidant for us. So how much is enough? Well, generally, we find that a glass of red wine is just about as good as maybe a bar of chocolate. And hold on, there's somebody wrote a question here. Let me just stop here and take this first question. Over the last few months, I've begun to experience interrupted sleep, then wake up, followed by 1 to 2 hours of attempting to fall back asleep, sometimes unsuccessfully. is this bimodal sleep pattern inevitable outcome of reaching the mid-50s. My similar age colleagues also report the exact same thing. Surprisingly, day sleepiness is not an issue for me, not yet anyway. And the simple answer is you already answered your question. It is indeed very much a factor of simply reaching your mid-50s. And I have bad news for you. It's going to get worse. What we know from sleep studies across the ages is that you had your best sleep, meaning you were most asleep during the night and most widely awake during the day, which are very related, when you were between 8 and 10 years old. And your sleep has been degenerating since then. And unfortunately, nothing we seem to eat really seems to help that. Don't I wish it did? Anyway, moving along then. So we're back to chocolate and wine, but I always get the question, what on earth should we be eating anyhow? And a study was just published a couple years ago where they looked at, as you can see, 22,000 people over 20 years. These kinds of studies are very, very expensive to do, but they ask important questions, which means, what should I avoid? What should I eat? What's the healthiest things? And you can see here that essentially what you've heard in the popular press, what Mom may have told you, is borne out in this very large, expensive study. That, you know, processed potatoes, meats, and so forth are not healthy. They're going to make men or women gain a lot of weight, whereas other things such as whole grains and nuts, vegetables are helpful, and that low-fat drinks are helpful. So it presented the obvious, but it presented it in a highly convincing fashion, and we were able to use this kind of information to tell people, look, it's okay to eat nuts. We know they're full of fat. You have to eat it in moderation. Cheese is quite a bit of fat as well, but again, in moderation, these things all seem to be quite helpful and are not harmful. But coffee is also more beneficial than just helping your donut affect brain acetylcholine. It's interesting in that if you drink about 5 cups a day of coffee, your incidence of getting neurological disease as you get older, like Parkinson's, seems to go down quite significantly, by about 85%. So there's a good reason to drink plenty of coffee during the day. Not only that, but now we're beginning to appreciate, as we interview people in their 80s and older, and ask them, you know, why are you not demented? What did you do differently? We're finding that some of them drank a lot of coffee, but now we're finding that some of these people in the 1970s and 1960s, who are now today in their 70s and 80s, smoked marijuana, and they're telling us about that. So many of the laboratories around the world, and here are some of the references if you're curious, have been investigating whether or not the marijuana these people smoked when they were younger, and as you can see, even older, had any benefit. And so I investigated this, and I looked at the brains of some inflamed animals that had a lot of oxidative stress. And what you're looking at there is all those red dots are inflamed, angry cells, and the blue dots are immune cells that have been activated by the oxygen and inflammatory molecules. And I can only tell you that that part of the brain is critical for learning and memory, and it is not functioning well. And what we found is that if we took these animals that had these inflamed brains who were very memory impaired and gave them the equivalent of 1 puff of marijuana a day, 1 puff a day, for 3 weeks, that all of the inflammation went away and the balance of activity in the brain went back to normal. And this effect was seen most dramatically in our aging animals. So it may be that as the brain gets older, the changes that induce memory impairments, we might be able to prevent by having people just take a puff. And so we made this t-shirt for our lab that a puff is enough if somebody can maintain that level without getting carried away. So it's always a balance that we have to be careful of. So what we find is that by studying marijuana in the brain, we see that when we eat a lot of fat, that the marijuana is produced, the anandamide is produced, and it makes us happy. So why is it when you're depressed that you eat a quart of ice cream that you become happier? Because the fat in the ice cream or the cheese or whatever it might be that you like is converted into anandamide, and that mimics marijuana, and we think that protects the brain from inflammation and the side bonus of making you a little happier. Someone decided to investigate this, and they invented a drug called rimonabant, you'll see over there, and when they gave it to people, it became the anti-Munchie drug. Individuals lost interest in eating, smoking, drinking. It was amazing. Unfortunately, we discovered something else about our brain's marijuana system, that we need it to keep us happy. And so the individuals who were taking this wonderful drug were losing weight. but they also became very depressed and had to stop the treatment. So that was out. So if we're not going to give you a pill such as an anti-Munchie drug, what's the other solution? Well, restrict how many carbon bonds you take in so that you don't need as much oxygen. Here's a couple of monkeys, Owen and Kanta, who are brothers, and as you can see, Owen was able to eat whatever he wanted whenever he wanted it, and his group had a real low survival rate. And if you look at Kanto, he actually was restricted, 1/3 fewer calories. So essentially, let's say he skipped dinner every day. 80% of his group survived. So clearly, not eating as much keeps you alive longer. Now, we no longer believe this extends life, but what it does, as you can see by comparing these two monkeys, is it makes whatever life you do have a little healthier. And it goes beyond this. I made the example of don't eat dinner. Well, that seems to be the key. There is an interaction with our biorhythm. It turns out that if we eat most of our calories early in our biorhythm, breakfast and lunch, we can actually get away with eating many more calories. It's dinner that seems to get us in trouble. And a study looked at this, and this is a busy slide, but I have it up if you want to stare at it later. But people who ate a high-calorie breakfast showed a loss of weight over time. But it's more important than that. During the day, after they ate a big breakfast, their glucose regulation, insulin levels were all normal. They did not feel hungry. They felt satiated, significantly healthier than people who were allowed to eat the same number of calories but spread throughout the day. So besides eating fewer calories, there's also an issue related to when you eat them. And it's best to eat most of your calories in the morning. So try and finish eating by 4 or 5 o'clock, which is tough to do in our culture. We are built around going out for dinners. But that seems to be what the data is telling us from the epidemiological studies and studies with animals. The benefits of not eating as many calories are sort of summarized here. If you simply skipped dinner, 1/3 fewer calories, look at what the benefits are. Liver cancers go down, lymphomas. In fact, all tumors that have been studied across now many, many species of animals all go down significantly. And it isn't just that you don't get tumors. Now you can see why a person might live longer and healthier. The function of our various tissues even improves. So kidney function doesn't degenerate. And look at the change there. With a normal diet, how often people tend to have kidney problems. Muscle degenerative diseases, heart disease, vascular problems. So not taking in the carbon bonds doesn't require you to bring in so many oxygen molecules, and the consequence is that, yes, you're thinner, but you age slower. So look at what this is implying. It's not that you want to be thin, it's that you want to avoid taking in calories. And I get this question a lot, and this is an important issue. What if you were to consume, let's say, 3,000 to 4,000 calories a day and exercised excessively? Well, look what it's doing. You're taking in a lot of carbon bonds. You need to consume a lot of oxygen. You are going to age your tissues faster. So all things being equal, if you want to live a long, healthy life, it's best to consume as few calories as possible. But there's a balance. You need to move around to strengthen your muscles, have good bone strength. So there's always this intermediate zone where we want to try and aim for, where eat is just enough calories for breakfast and lunch. And be an omnivore. Try to eat a little of everything. We have never found that any particular carbon bond is better or worse than another carbon bond. So, the idea of just eating carbohydrates or proteins or whatever only does not hold up when it comes to these kinds of long-term studies of the health of our tissues. So my advice is simply eat breakfast and lunch, eat a big breakfast like a king, lunch like a prince, and dinner like a pauper. And that's probably the healthiest thing you can do for your body. So what's the solution? Less eating or more exercise. This comes up all the time. Simple exercise in our bodies, the way we're built, contributes very little to weight loss. And anybody who's joined the gym after, New Year's Eve, or when they've made a resolution, realizes that they really don't lose weight very quickly. Our bodies are not designed to lose weight by that fashion. Now, if you become a marathon runner or you're swimming a lot, certainly physical activity will consume more energy. But for most of us who are not marathon runners, physical activity does not account for much of a percentage. 80% of the energy we use is simply to maintain our bodies when we're just sitting, lying still. So the interesting thing that recently I saw in the newspaper was the people who organize and run the TV show The Biggest Loser. The gentleman was interviewed, and he said when he first started this program, he thought exercise was of vital importance, with of course, a good diet. But now, after many years of doing the show, he's come to the conclusion that the most important thing is not exercise, but diet. Simply eat less. Here's an approach. You could add a tapeworm to your diet and let the tapeworm eat the food for you. And believe it or not, these things are actually coming back into vogue. But I wouldn't recommend it. So what's the take-home message then? Let me summarize this in the last 5 minutes here so that we have time for questions. What you eat may affect brain function. You've seen that. But it does depend on how often and how much you consume. And what is it? Obviously, right? Is it coffee? Is it a donut? Is it chocolate? A single good dietary habit is not enough. You really have to have a balance of many different things. This is why I always encourage people just to be an omnivore. Eat a little bit of everything. And don't worry about getting every nutrient every day. Just think about it in terms of, well, this week, how many times did I eat vegetables or fruits or protein? In other words, don't become too obsessive about it. Overeating impairs cognitive function. Why? Because overeating produces a lot of fat cells. And the bigger our fat cells are, the more inflammation and the more oxidative stress our bodies are under. So we have found that individuals who carry a lot of body fat will be more depressed and have more cognitive impairments. And what's sad is that when we give these people SSRIs to enhance serotonin function, we find that obese individuals do not respond to them as well as a thin person. So most psychiatrists, when they have an overweight individual who's depressed, will also recommend lose weight. And that's the reason why. So the idea then to live long and have a healthy brain is simply to eat as little food as possible. You can see how counter that is to our culture. No restaurant out there has a sign that says, come on in, have a seat, and eat nothing. That's not how it works. But calorie restriction is the only valid, scientifically proven dietary intervention that's ever been shown to slow aging. Nothing else works. You can certainly find lots of things on the internet that will make claims, but none of those are true. It's just a way to make money. The only way we know to maintain good brain function as we age is to do everything possible to keep the oxygen out, which means to eat fewer calories. And you've seen some things that we've discovered that's reduced brain inflammation, reduce oxidative stress. And I think the positive take-home message from this, besides just being omnivore, is it's never too late to slow brain aging. So even in individuals like old animals and old people who are changing their dietary habits have found that they can benefit from those changes. So I think that's the most positive thing I think I can leave you with, is simply to say it's not too late, no matter how old or how young you are, to stop eating so much and slow down your aging process. So with that hopefully positive thought, let me move on. And this on the left side is a book that I'm actually in the process of editing for a second edition to add in more food comments, some of those that I've discussed here, and as well many more, and ask if there are any questions. And so I'll stop talking and see if any of you would like to say something.
I'm just going to interject here and say that if you want to ask a question and you want me to unmute you, please raise your hand. It's a function next to the questions. Okay, we've got a question from Karen Hambright. I'm going to unmute you. Karen? Hello?
Hi, Karen. Can you hear me?
We've got some other questions. I'll just read them out loud.
All right.
Okay. Okay. How does the relationship between exercise and oxygen intake relate to brain health? Is exercise bad in a sense?
That is a conclusion from the things I've said. That's a fair assessment. Yes, it is, which is strange, isn't it? So if you, as I commented before, started to talk about, if you took two individuals who are genetically identical and had one of them, and let's say that they both weigh the same amount, two women, and they both weigh 120 pounds. If one of them exercises extensively and eats 3,000 or 4,000 calories a day and still maintains her weight at 120 pounds, we've often wondered, why do skinny people show this aging process when that should be beneficial? I mean, you look at them and they look so healthy. But now that we're collecting evidence from the epidemiological studies that are done by health insurance companies and so forth, is that all things being equal, extreme exercising will age your body and brain faster. That's what these diet restriction studies have demonstrated to us over and over again. But you've got to find a happy medium. I'm not recommending that somebody become a couch potato and just sit there and, you know, atrophy their muscles and have osteoporosis. No one wants to live that kind of life. So obviously you need to get up and move around. You need to do weight-bearing exercises. What we would suggest is that, you know, 20 minutes a day or during a day, maybe 3 times a week, to do something aerobic and also vary your exercises, do different things, seems to be the ideal. That both gets you the exercise, keeps you, you know, strong and physically active, strengthens your cardiovascular system, but also doesn't put great demands on oxidative stress.
Okay, thank you. We have some more questions.
Go ahead.
And this one comes from Katie, and this says, when you say eat as little as possible, how many calories per day are you talking about?
As you might guess, that ends up being important, doesn't it? Because everyone has a slightly different body weight that they're beginning with. If you look at the standards for 2,000 calories a day, that is probably too high. When we do these studies with primates, and enough of them have been done now, so we can make generalizations to humans, when we suggest that a person not eat dinner, what it really translates into is about 1/3 fewer calories. So if you're eating 2,000 calories a day, in the old diet, it would be to go to, say, 1,300 calories. I mean, that's not easy, and we don't recommend that anybody just do that overnight because food is addicting. And just in the same way, if I took away 1/3 of your heroin, a heroin addict would be very uncomfortable. Our brains respond the same way. So essentially then, what we need to do is treat the food like heroin and very slowly, or nicotine, and very slowly take it away. So eat a little bit less every night for dinner is a nice way to start. Don't think of it as you want to make a Herculean change on day one. You won't succeed. Our brains will demand that we go get the chemical that it has become addicted to. And that's why I brought up that point. You really need to see food as addicting as nicotine and heroin. And if you treat it that way and understand that your brain's going to crave it, you realize you can't go cold turkey on calories, just like you can't easily do the same thing with nicotine. So very gradually over the next year, slowly cut out virtually an entire 1/3 of your calories. I think you'll find it's a little easier to succeed.
Thank you. And I have Karen's question right here. And she's curious about marijuana in the elderly and the effects. Are effects not harmful to hippocampus and memory as we've been told?
Well, that's an interesting, the short answer is yes, but and this is what's odd. The study I quoted, I didn't elaborate on it, but we compared the effects of that 1 puff a day on young animals, such as my college students, and what we find is the same thing that many students find, that even at 1 puff a day, in the young brain, you see memory impairment. Even at that low of a dose, because it's such a fat soluble molecule, it tends to build up, and over time will impair memory. So that is still true. What we found that was so interesting is that in the aging brain, where there already are these changes that are causing a memory impairment, that the 1 puff a day tended to remove the cause of the impairment. So we did not make our young rats as smart as we did not make our old rats as smart as our young rats. They are not super, rats, just like we don't believe that we would make old people as smart as, an 18-year-old. But the key thing is that the mechanisms that underlie the brain's degenerative changes as we get older are sensitive to the chemicals in marijuana and will reverse it. And that was what we found that was so exciting. And that, we believe, explains the epidemiological evidence of why people who were in their 20s and 30s who smoked marijuana now are finding that their brains aged more slowly during the past 30 years. So you can see that when it comes to dosing your brain with chemicals, it can have negative short-term effects, but positive long-term effects. Let me just continue. Nicotine is another compound like this. Smoking, cigarette smoke is a very powerful metal chelator. And if you happen to work around heavy metals, you might want to smoke. If you grew up in a rural environment in America, you're at great risk of getting Parkinson's disease. And we know from epidemiological studies that smoking prevents Parkinson's disease. It's incredibly neuroprotective. But would you recommend that somebody smoke cigarettes if they're at risk? It's hard to say. But if they were already smoking and they grew up in a rural environment, you might second guess it and say maybe we should just let them go. If they didn't get lung cancer, we might have prevented the Parkinson's. So you can see you have to sort of choose your conditions and then choose the molecule and ask, do I need this? Will it help me? And the rules change. When you're young, you respond to marijuana in one way. When you're old, you respond to the same drug in a different way. So that's what makes these things so difficult to predict for people.
Okay, thank you. Does anyone else have any questions? Okay. So I'll be sending out a follow-up email that will have a link to a short webinar survey, and we would very much appreciate it if you could all fill it out so we can improve our webinars going forward. Another note, we will have a recording up on YouTube if you're interested in watching the session again. Please feel free to be in touch if you have any questions at all. And once again, I just want to thank you everyone for attending today and for sharing your good thoughts with us. And also a big thank you to Gary Wenk for presenting.
Thank you.
Have a good day. You're welcome.